Hey guys, welcome back to another video, and today we're going to take a look at the LeetCode question, count sorted vowel strings. Alright, so in this question, we're given an integer n, and the goal is to return the number of strings of length n. So whatever strings we have has to have a length of n, and these strings can only consist of the vowels. So the vowels are A, E, I, O, U, and these are lexicographically sorted. Now, what does it mean for something to be lexicographically sorted? So, for example, for something to be lexicographically sorted, it has to be in the order of A, B, C, D, E, F, and so on and so forth, right? So A is going to hold the smallest value, and Z or Z, however you call it, is going to be the largest value that we have. So in this case, for example, how would this be in lexicographical order? So E would come after A, right? I comes after E, O comes after I, and U comes after O. Okay, so this over here is the lexicographical order. Now, another thing that you do want to kind of notice is when you have AA, right? So when you have two of the same letters, that is also considered to be in lexicographical order. So that's basically what we're looking for. And this is the question. Now, when I first saw this question, the first thing that came to my mind is that I could use a combinations formula in math. So it's kind of a formula that I already knew. So you could just directly implement that and get the answer. But one thing I do want to do over here is kind of show you how we can represent it step by step and how we can actually end up getting the final answer. So let's just see how that looks like. Okay, so let's start off with the basic explanation of how we could solve this. So let's start off with what exactly our vowels are, just to kind of write it down so you just have an idea of that. Actually, let me just close this. Okay, so the vowels that we have are going to be A, E, I, O, U, right? So those are the vowels, and this is the lexicographical order of them. Now, keeping this in mind, we're going to be given a n value. Now, n is basically the length of a string, okay? So n is the length of string, and the string has to be of that length. Now, let's start off with a very simple example. What if we have a length of 1, okay? So n is equal to 1. Now, what that tells us is a string can have a length of 1, or it has to have a length of 1. So what are our options going to look like? So we can have A by itself, we can have E by itself, I by itself, O by itself, and U by itself. Now, if you look at this, we have 5 different answers. So we're going to end up returning a value of 5. Okay, pretty simple. Now, let's just take it up to 2, okay? So over here, you should kind of be able to find a pattern. So try to just understand what the pattern looks like, and then we'll try to implement it. So when we have n equals 2, we have to have a length of 2. So what I'm going to do is I'm going to kind of have 2 empty boxes, for example, right? So this would be letter 1, I'll just call it L1, and we have letter 2 over there. So 2 different letters, and they're going to be there. Now remember, these letters, whatever it is, has to be in lexicographical order, and they have to have a length of 2 in this case, which we're already accounting for. Now let's just write down what are all of the possibilities one could have inside of each of these positions. Now over here, we could have either the letter A, E, I, O, or U, right? These are the possibilities. And those are the 5 vowels. And I also wrote them from the lowest to highest order from top to down. Okay? Now over here, we also have the same values. Now remember, we can repeat values, right? So we can repeat, okay? So keeping that in mind, we can have A8. That is a possibility. And A8 is going to be in lexicographical order. So the possibilities are A, E, I, O, U. Okay, so now what I kind of want to show you is how exactly do we get an answer out of this and try to show you what the pattern is. Now what we're going to do is we're going to kind of set a value for the first letter. Now what we're going to say is A over here is going to be our first letter no matter what, unless we actually have to switch. So we're going to say A is the first letter. Now once we have A as the first letter, we need to come up with the second letter. Now the question is, how many possibilities do we have for that? So to come up with that, one possibility is having the letter AA. That's one possibility. Now the second possibility is we could have the letter AE. Now again, remember, these are all in lexicographical order. Now the next possibility is AI, and then AU, AO, and then AU. So you can kind of understand how so AA, AE, AI, AO, and AU are all possible solutions. So how many possible solutions does this give us with A as the starting string? So when A is the starting string, we have 1, 2, 3, 4, 5 possibilities. So we're going to just write that down for here, okay? So A gives us 5 possible solutions. Perfect. Now what happened is that we've actually exhausted all of the possible solutions for A to have. Now over here, we've tried out all the 5 possibilities and there's nothing else. So since we're kind of done with all of the possibilities, we're now going to go back over here. So this is where kind of the name of the formula comes, backtracking, or algorithm, sorry. So we're going back one step, since at this step currently here, we've tried out everything. So now we're going back one step here. And now, since we're done with A, we're going to kind of cross it out, or I'll just put a tick mark. And now we have E, okay? So we're going to just put E as the first letter. Now what we want to do is find out all of the possible second letters with the value E being the first letter, okay? So one thing we could do is we could have EA, right? Now the thing with EA is that this does not follow lexicographical order. So this over here is wrong. We cannot use A. Now the next possibility is the letter E. So EE is a possibility. So that's one possibility. Then we have EI, EO, and EU. Now that gives us 4 possibilities, okay? I'm pretty sure you can kind of see the pattern, so I'll just go through this a little bit faster, okay? So now we're at I, and I is going to be our first letter. And what that tells us is the next possible values is that we cannot have IA because that's not lexicographically correct. So let's cross it out, and let's also cross out E. Now the only values we have are II, IO, IU. So that gives us, with I in the beginning, we have 3 possibilities. Now let's go down to O. Okay, I'll just do for O real quickly. So for O, our possibilities are OO, OU. Pretty simple, 2 possibilities. And finally, we're down at U. Sorry, my U looks like a 4, but yeah. So U, and what is the possibility here? We only have 1 possibility, which is UU. So in this case, with U, we have 1 possibility. Now the question is, what is our final answer? Sure, we got these numbers. Now the final answer is just going to be the addition or the sum of all of these, because with A as the beginning, we have 5 possibilities. With E as the beginning, 4, I 3, O 2, U 1. So when you add these all up, you get 5 plus 4, 9, 9 plus 3, 12, 12 plus 2, 14, 14 plus 1, 15. So for n is equal to 2, we have a total of 15 values. And if you go back over here, for n equals 2, it's 15 values. And these are the possibilities they gave. And if you want to compare it, it's going to be exactly the same. But one thing you want to keep in mind is that this doesn't really matter. We just want the output value, okay? Perfect. So now what I'm going to do real quickly is now let's just do for n equals 3. And while we're doing it, we'll come up and I'll explain the backtracking solution to you. All right, so perfect. So over here we have n is equal to 3. Now real quickly, same steps apply. We have 3 blank values that need to be filled. And the idea is going to be exactly the same thing. A, E, I, O, U are the possibilities for this. And the possibilities for the second word, letter, are going to be the same. And finally, for the last letter, the possibilities are going to be exactly the same. Now, over here, what we're going to do is the same thing. What we're first going to do is we're going to set A as a value for sure, right? So A is going to be one of the values. Now, over here, we're going to do A as the other value, right? So over here, A is going to be our next value for sure. Now, we have 2 values that are set. And the only value that is kind of variable for now is going to be this value. So over here, what are the possibilities? So over here, we can have the possibility of A, E, I, O, and U. So that really tells us we have 5 possibilities as it is with A, and some value over here. Now what we're going to do is, since we got all of the values here, we're going to go back one step, right? So we're going to go back one step and look at the next option for this. So the next option for this is going to be AE, right? So AE is the next option. And at AE, we're going to try all of its probabilities. So this is what we're trying to find out. So in this case, we can have 1, 2, 3, and 4, okay? So that's going to be 5 plus 4, okay? So you keep going down, right? Now you're done with this, so you move back one step. And over here, now you try out everything with I, okay? So when you try out with I, you're going to get 3. I'm just going to go through this real quickly. Then when you go with O, you're going to get 2. So plus 2. And when you go with U, you get 1. Perfect. Now what happens is you tried out everything over here. So now you move back a step and you're currently at U. And even over here, you've actually ended up trying out everything. This is also completely done. Now the question is, what do we do now? So now again, the simple solution is we go back another step. So now we're going to go back another step, and now we're going to try the values that are over here. So in this case, we're basically telling we're done with all possibilities of A. Now the next possibility is going to be the letter E. And now we're going to just repeat the entire process. So we're going to set E over here. Now over here, we're going to start off with E. Obviously, we can't have A because, well, it's not in lexicographical order. So this actually would now give us a value of 4 plus 3 plus 2 plus 1. And I'm just going to write it down real quickly. So this would not, the next thing, when we have I in the very beginning here, we would actually have 3 plus 2 plus 1, and then 2 plus 1 for when we have O in the beginning. And when we have U in the beginning, the only possibility is U, right? So U is the only possibilities. So that gives us a value of 1. Now, when you add all of these values, we're going to end up getting our final answer. So now the basic idea here is at each position, we're going to try out all of the possible solutions. And the way we're going to do this is we're going to break down our problem. So in the beginning, we have n is equal to 3. So what we did is we set the value to A. Now, all we really need to worry about is these two values over here. So you can break this problem down furthermore. So you can just treat these two as n is equal to 2, right? We're just treating it as a smaller version of the problem. So when this is kind of n is equal to 2, we're going to do the same steps. Over here, we're going to kind of start off with a value of A. And now when we're over here, we're going to try out all of these possibilities. Okay, now once you go down, what we're going to do is we're not actually going to go letter by letter. We'll just assign values, right, of number values. So what we're going to do in this case, we're going to iterate 5 times because we have 5 possibilities. But now for the next time, what we're going to do is we go back one step and we're going to be at E. And when we have E over here, we only have 4 possibilities. So we're going to iterate over it 4 times. Then when we have I, we do it 2 times and then 1 time. And at one point, we're going to be at 0 times. And at that case, what's going to happen is we exit this mini problem kind of, and we go back over here, right, to the main kind of problem and look at its next value, which is, like I said earlier, in the beginning, we had 5 options. Now we're only going to have 4 options left, right? So you can kind of assume as that being E. Now, again, we repeat the same steps over here. So over here, we have 4 possible options. Over here, we have 4 possible options. Then this comes down to 3, then 2, and then 1, and then 0. And then at that point, what's going to happen is this now comes to 3, and then we try all of its solutions, and so on and so forth. So hopefully you can kind of understand how you could come up with a recursive solution, or in other words, to be more specific, a backtracking solution. So let's just kind of implement this in code, and then I'll show you the mathematical formula. Okay, let's just start off by implementing this in Python. So what we're going to do is let's define a helper function over here. And this helper function is going to take 2 values. So the first one is going to be the n value, and the second one is going to be the vowel, okay? So the vowel is going to basically tell us at which vowel are we currently on. And we could actually just use the letters itself to indicate that. But what we're going to do instead is we're going to use numbers. So we're going to use the numbers 0, 1, 2, 3, 4, and 5. Actually, it's just going to be up to 4, sorry. So this is hard for you to understand. Just visualize them as being indexes. So you could think of them A, E, I, O, U. So 0 represents A, 1 represents E, 2 represents I, 3, O, 4, U, and I'm pretty sure you get it, okay? So that's basically what we're kind of using in this case. So over here in our helper function, the first thing we're going to do is we need to actually find a result, okay? So the result is going to be, well, the number of possibilities. And we're going to start off with a value of 0. Now what we're going to do is we're going to go inside of a for loop. Now this for loop over here, let's just do it for x in range. And what exactly is the range of this going to be? So what we're going to do is we're going to start off at the current, whatever the vowel value is. And we're going to go all the way up to 5. Now, why exactly does this make sense? So what basically happens is our vowel is going to start off at 0 because in the beginning, we all have all possible letters. We have A, E, I, O, and U. Now, at this condition, what happens is we go 0, 1, 2, 3, 4. Now, that's a total of 5 times. So in the beginning, we iterate over it 5 times. Now, I'll try to explain how this is going to change. Now, what we're going to do is each time, like I said, we're kind of breaking down this question into smaller parts. Now, in this case, what we're going to do now is we're going to call this helper function on itself. We're going to call it recursively. And over here, the n value is going to decrease by 1. So kind of think of it like this, right? So over here we had, okay, so over here, currently we had 5 possibilities in the very beginning. Now over here, we also have 5 possibilities, but over here the n value was kind of 3, and now we just broke it down into a smaller problem where the n is just 2. So over here, we're going to decrease the n value by 1. And the other thing that we're going to do is for our function, what is the vowel value going to be? Now the vowel value is going to start off at x. And the reason for that is pretty simple. So the reason we're starting off at x and not x plus 1 is because the values can be repeated. We can have AA. So in that case, we're going to start off with the x value itself. So hopefully it is making sense. And finally, now what we're going to do is we're going to add this to our result. So result plus equals this. Okay, now there's 2 things that we actually want to end up considering. What happens when n is equal to 0? Now, if n is equal to 0, that's one condition we want to talk about. What we're going to end up doing is we're going to return a value of 1, okay? So when n is equal to 0, we return 1. And the other condition that we kind of want to look at, what happens once we leave this while loop, for loop over here? Then that's pretty simple. All we need to do is we need to return our result. Now that's it for our helper function. And finally, all we need to do is we need to call this function. So for calling it, we're going to have helper. The n value is going to be same as whatever we're given in the question. So helper n, and the value of vowel is going to start off at 0, okay? And that basically represents A. So if you submit this, it should get accepted. And now let's look at the same thing in Java. Okay, so over here, we're first going to end up creating a helper method. And this is what we're going to be calling recursively. So it's going to be int helper. And what exactly are we going to take inside over here? So we're going to take in the n value. And we're also going to take in the vowel, so int vowel. So these are the 2 things that we're taking into our function over here. Now, what exactly do we do over here? So the first thing we want to do is we want to initialize a value of the result. So int res is equal to 0, and this basically tells us the possibilities or the number of possibilities that we're going to have at a certain point. Now we want to go into the backtracking part of the solution. So for the backtracking part, we're going to go in a for loop, right? So the for loop is going to be int, and we're going to have a I value over here, and the I is going to be equal to whatever vowel we're currently on, okay? So for example, if we're at 0, we're going to start iterating at 0, okay? If we're at 1, we're going to start at 1, perfect. Now this is going to keep increasing by 1, and we're going to go all the way up to I is less than 5, okay? So it's going to be I less than 5. So that's basically 5 iterations, 0, 1, 2, 3, 4, total of 5. Now finally, we need to increment it, so I plus plus. Okay, now inside of this for loop, what we're going to do is we're going to call this function on itself, right? And over here, we're going to actually decrease the n value by 1. So we're going to end up with n minus 1. And like I showed you earlier, the reason for this is at each point. So over here, we kind of are solving a n is equal to 3 problem. But now when we go to the next step, we can just kind of think of it as a smaller problem, which is just n is equal to 2, right? So that's basically what we're trying to do over there. So that's why we decrease n by 1. And over here, you might think for the vowel, we would increase it by 1. But actually, for the vowel, we're going to leave it as it is. So it's just going to have a value of I. And the reason we're not doing I plus 1 is because we can have a possibility of the same letter being repeated. So that means we can have AA or UU. So that's why we start off, we're going to have the value I over here. So over here, we're going to have helper n minus 1 I, and this value is going to get added to our result. So res plus equals, and we're going to add it to that. Perfect. Now, outside of this while loop, all we need to do is we need to return our result. Now, one condition that we want to make sure we consider is what if, or it's going to happen, is what happens when this n value over here becomes 0. Now, in that condition, we're just directly going to end up returning 1. So if n is equal to 0, then in that case, we're going to end up returning a value of 1. Okay, so that should be it for our helper method over here. And now we need to call it inside of our inside of this method over here. So to do that, we're going to have helper. And what is going to be the n value? So the n value is going to be same as whatever we get from here. So we're going to have n over there. Now, what is going to be our vowel? So in the beginning, we're always going to start off with all possibilities. So we're going to start off at 0. What that tells us is we have we're going to start off at A basically, and then after that we have all other values that are possible. So A, E, I, O, U. So we're going to start off at 0, and then we're going to go into for loop and so on and so forth until we actually get all of the possibilities. Then we return the result, and over here we need to return that value. So return helper and comma 0, and this should be it for our solution. Okay, and actually, sorry, one small mistake. This is supposed to be if n is equal to 0. Sorry. Okay, so now let's take a quick look at the math solution for this. Okay, so the formula over here is basically the number of combinations we have with repetitions, right? Because the values can be repeated. So with repetitions. Okay, sorry, my handwriting is really bad. Okay, so in this case, what exactly is the formula? So this is how the formula looks like. So we have a n value and a k value. Now, what does n and k mean? So n over here is actually going to be kind of the length of the string. So length, okay, let me try writing that better. Okay. So n is going to be equal to the length of our string. And the k value is the number of possible values that we might have. So in this case, the k value is going to be equal to 5 because we have 5 vowels, okay? Now the formula for this is this over here is going to be equal to n plus k minus 1, so in the NCR format, and then k on the bottom, okay? Now, how exactly do we write this in a way which is easy for us to compute? So basically, when you write this, you're going to have n plus k minus 1 factorial divided by n factorial multiplied by the k value minus 1 factorial. So real quickly, what does factorial mean? So basically, let's say we had something like 5 factorial. This is equal to 5 multiplied by 5 minus 1 multiplied by 5 minus 1 minus 1 multiplied by 5 minus 1 minus 1 minus 1. So I'm pretty sure you understand what I mean, right? So in simple words, this is equal to 5 into 4 into 3 into 2, and we're going to go all the way until into 1. After that, we stop. So 5 factorial is 5 into 4 into 3 into 2 into 1. Okay, so that's basically what a factorial is. Okay, so now keeping that in mind, we can actually simplify our factorial. So like I showed you, 5 factorial is nothing else but 5 multiplied by 5 minus 1, right? So let's use the same logic and simplify the equation that we have over here. So this is now going to be equal to, so let's just simplify this. Okay. And actually before simplifying it, one thing that we know for a fact is that the k value is going to be equal to 5. So let's just plug that in. So since the k value is 5, this would be n plus k minus 1, which is 5 minus 1, which is equal to 4. So n plus 4 factorial divided by n factorial multiplied by the k value over here, which is 5 minus 1. So that's 4 factorial, okay? So the first thing that we're going to do is try to simplify this, and I'll show you how this exactly works. So n plus 4 factorial is going to be the same as n plus 4 multiplied by n plus 4 minus 1, which is nothing else but n plus 4 minus 1, which is n plus 3, sorry. Okay, so that's that, and multiply this by n plus 3 minus 1. So n plus 3 minus 1 is n plus 2. Then multiplied by n plus 1, and finally multiplied by n. Now this is going to keep going. So since we don't know where it stops, what we can just directly do is multiply by n factorial, okay? Now all of this gets divided by n factorial, and now we need to account for 4 factorial. So we can just get the value by itself. So that's 4 into 3 into 2 into 1. So that is nothing else but 4 into 3, which is 12. 12 into 2, 24. 24 into 1, 24. So this over here is equal to 24. Okay, can we simplify this anymore? And we can. So really simply, we get rid of the n factorial here and get rid of the n factorial here. They cancel each other out. So now this is the formula that we have. So I'm not going to actually code it out. It's really simple. All you need to do is just plug in this formula and it will give you the answer, okay? In this case, all you're going to plug in is n plus 4 multiplied by n plus 3 multiplied by n plus 2 multiplied by n plus 1. All of that divided by 24 is going to give you the final answer, okay? So that should be it using the math combination formula, and that should be it. So thanks a lot for watching, guys, and do let me know if you have any questions.